Welcome back to Physics Miss McQueary. Today we're going to be talking about controlled experiments. All right, now we got kind of a lengthy learning target today. We're going to be breaking it down into several manageable chunks that we can tackle one at a time. All right. For example, we can separate controlled experiment, determining what that is, figuring out which measuring devices to use, and then what do we consider relevant data. So really we're going to take this learning target and split it down into manageable chunks, like so. What are independent and dependent variables? What is a constant? What is the effect of multiple measurements on an experiment? And then what tools do I need in order to get the data that I need? All right. The first one, you've heard it 1,000 times, independent and dependent variable. Now, the last video we discussed where an independent variable and a dependent variable go on a graph. Remember, the independent variable goes on the x-axis and a dependent variable goes on the y-axis. Okay? Now let's dive deeper into what those actually mean. An independent variable is what you're actually changing. Okay? For example, in the example below, the amount of water is what we're actually changing. And in fact, we're changing these and we control these. These are things we're changing on purpose. Okay? A dependent variable is what is affected by that change. And it's a thing that we're actually measuring. So when you write things down in your data table, it's usually the dependent variable that you're writing on there. The dependent variable in this case could mean how big the plant got. Is it green versus brown and dead looking? How many leaves do you have? All those are examples of dependent variables that are affected by the amount of water. So a quick way to double check is if you look at an experiment, try to determine what something is affected by. All right, the thing that's affected is the dependent variable. The thing it's affected by is the independent variable. At this time, you're going to be watching a couple of videos from the Mythbusters. We're going to work to determine the independent and dependent variable. Look down in the description below to get the links to those videos. If you want to work it out yourself, go ahead and pause this video. Hopefully, you were able to watch the video. In this case, the independent variable is the presence of dimples. We had one car which was smooth and clay. The other one was still clay, but it had dimples there. Those are things we changed on purpose to try to test. So the independent variable is the presence of dimples. The dependent variable, the thing we're actually measuring, the thing we're hoping to affect, was the fuel efficiency. Remember they said something about 26 miles per hour versus, or miles per gallon versus 29. So the dependent variable in this case is the fuel efficiency. And it turns out a dimpled car really does help with your fuel efficiency. That's the dependent variable. Our next example is the classic, do I walk or run in the rain? Once again, we're looking for the independent and dependent variable. At this time, you can pause the video to watch it for yourself and then come back. Hopefully you had a chance to watch the video. In this case, the independent variable was the speed of the movement. Walking versus running. That is what they were testing. The dependent variable, the thing that was affected by it, was the weight of the rain collected. In this case, it was their cotton jumpsuits, and they were measuring the amount of weight they had put on in grams because of the speed of the movement. If you need more help with this, maybe watch those videos again and then try it once more. The next topic we're going to be determining is what is a constant or a control. AKA, it's what you keep the same throughout the entire experiment. You can change your independent variables, but everything else should remain the same. You don't want to be testing multiple variables at the same time. Otherwise, it could be a number of variables that change the dependent variable instead of just one. So really, we're looking for isolation. How many things can we keep the same besides our independent variable? Once again, it's Mythbusters time. Only this time you're watching to find out what is the control. So Two of these will remain the same for both of the experiments. One of them will remain the same. Can you figure it out? Hopefully you had a chance to watch the video. In this case, it's the presence of a mouse that is not a control, because the timing of the pool was roughly similar both times. The pile of dung was there for both instances. The only difference was one trial didn't have a mouse, the other one did. Therefore, it's not a control because it didn't stay the same. Actually, the presence of a mouse is our independent variable. The next topic we're going to cover is the importance of multiple measurements. Take these two mechanics. One guy has been working for 20 years with the same company. The other one started last week. Which one are you most likely to trust your car with? It's probably the guy on the left with most experience. He has a proven track record of numerous years of quality work. The guy on the right is less proven. He may be a good mechanic, but you don't have a whole lot of data to go off of. The same thing can be true with sports. For example, on the left, Jeremy Lin had an incredible run where he was one of the better players in the NBA. Unfortunately, it was rather short, and for the rest of his career, he hasn't been quite to that level. We now know with this data that Jeremy Lin is not necessarily one of the better players in the NBA. But if you watch for maybe a few weeks back in his prime, you would have thought that. The same thing with Tim Tebow. He did have a great run with the Denver Broncos and actually won a game in the playoffs. Unfortunately, the rest of his career, he spent as a backup or as a little used player. If we look at his career as a whole, we can see that he was not an all-caliber quarterback. But specifically in fourth quarters for that 1 year, if you're just looking at that, it may skew your data to look like he's a great quarterback. The same can be said with other things. Try flipping a coin. There should be about a 50-50 chance of tails versus heads. But if you only flip it, let's say 4 or 6 times, you might get some results that don't quite line up with that. Now try to flip it several hundred times, and you'll see that it starts to approach 50% for both outcomes. More trials equals more reliable results. The last topic is tools. What tools do we need to measure certain things? On the left, we have what we're actually measuring, and on the right, what tool we need for that. Not all of these will work every time. For example, for length, if you want to measure something very, very small, a meter stick might not be the tool you want to use. Maybe calipers would be better. Or if you have a much larger object that you're going to be measuring, you might not need a meter stick. You might need something much larger than that. The same thing is true with a weight. Normal scales that you see, like balance beams, are good for small objects, but maybe not always for your massive ones. Like, for example, cargo freights. At this point, we've covered all of our topics. We've talked about how independent variables are the ones that affect your dependent variables. Constants are the things that you keep controlled, aka the same, between all of your trials. We realized that multiple measurements means more consistent results. And finally, we realized that we need certain tools in order to measure certain quantities. Until next time, see ya.